Bluetooth. It's a name synonymous with wireless connectivity. But why Bluetooth? The story takes us back to the 10th century, to a Viking king named Harald Bluetooth. King Harald was famed for unifying the tribes of Denmark and Norway. This unifying spirit is mirrored in Bluetooth technology. The name was chosen to reflect its goal, to unite various electronic devices wirelessly. The Bluetooth logo is even a bind rune, a combination of two runes representing Harald's initials. In 1994, a group of companies including Ericsson, IBM, Intel, Nokia, and Toshiba formed the Bluetooth Special Interest Group, SIG. Their aim was to develop a short-range wireless technology standard. They wanted to replace cables connecting devices like mobile phones and headsets. The SIG's vision has become a reality. Bluetooth is now ubiquitous. It seamlessly connects billions of devices worldwide. From smartphones and laptops to headphones and smart home gadgets, Bluetooth has revolutionized how we interact with technology. Bluetooth utilizes a clever technique called frequency hopping spread spectrum, or FHSS. It rapidly switches between 79 frequencies within the 2.4 GHz band. This hopping happens 1,600 times per second, making it difficult for interference to disrupt the signal. Imagine a busy highway with multiple lanes. Cars constantly change lanes, avoiding collisions. Bluetooth works similarly. Its signal hops between frequencies, dodging interference from other devices like Wi-Fi routers and microwaves. When two Bluetooth devices want to connect, they go through a process called pairing. This involves exchanging unique identification codes to establish a secure connection. Think of it as two spies sharing secret passwords before exchanging confidential information. Bluetooth employs various security measures to protect data during transmission. These include encryption and authentication. Encryption scrambles data, making it unreadable to unauthorized parties. Authentication verifies the identity of the connecting devices, ensuring that you're connecting to the intended device. Bluetooth has undergone significant evolution since its inception. Version 1.0, released in 1999, was a groundbreaking achievement. It established the foundation for wireless communication between devices. However, it had limitations in terms of data transfer speeds and range. Subsequent versions introduced improvements. Bluetooth 2.0 brought faster data rates, enhancing the user experience. Bluetooth 3.0 further increased data transfer speeds, enabling more demanding applications like streaming high-quality audio and video. Bluetooth 4.0 was a major leap forward. It introduced Bluetooth Low Energy, or BLE, a game-changer for wearable technology and the Internet of Things, IoT. BLE significantly reduced power consumption, extending battery life for small battery-powered devices. Bluetooth 5.0 arrived in 2016, further enhancing data rates and extending range. It also introduced features like dual audio, allowing you to stream audio to two devices simultaneously. The latest versions, Bluetooth 5.1 and 5.2, refine existing features and pave the way for future innovations. One of Bluetooth's most popular applications is audio streaming. Wireless headphones and speakers have become ubiquitous, freeing us from tangled wires. Bluetooth audio relies on codecs, which compress audio data for efficient transmission. Different Bluetooth versions support various codecs, each with its own strengths and weaknesses. SBC, the standard codec, is widely compatible but offers basic audio quality. AAC, popular in Apple devices, provides better audio fidelity. aptX, developed by Qualcomm, delivers high-quality audio comparable to wired connections. Bluetooth audio has transformed how we listen to music, podcasts, and audiobooks. We can enjoy our favorite tunes while exercising, commuting, or simply relaxing at home. Wireless headphones provide freedom of movement, enhancing our listening experience. Bluetooth speakers have also become increasingly popular. They allow us to share music with friends and family, creating a party atmosphere anywhere. Portable Bluetooth speakers are ideal for outdoor gatherings, picnics, and beach trips. Bluetooth plays a critical role in the Internet of Things, or IoT, which refers to the interconnected network of devices that collect and exchange data. Its low energy consumption makes it ideal for connecting small, battery-powered devices like sensors, wearables, and smart home gadgets. Imagine a smart home where your lights, thermostat, and appliances communicate with each other wirelessly. Bluetooth enables this seamless connectivity, creating a more comfortable and efficient living environment. Smartwatches and fitness trackers use Bluetooth to sync data with smartphones, providing insights into our health and activity levels. Moreover, Bluetooth sensors are transforming industries. In manufacturing, these sensors monitor equipment performance, optimizing efficiency and reducing downtime. In agriculture, sensors track soil conditions and crop growth, enabling farmers to make data-driven decisions. The possibilities of Bluetooth in the IoT are endless. As technology advances, we can expect even more innovative applications that improve our lives and solve real-world problems. Bluetooth is making significant contributions to the healthcare industry. Medical devices are increasingly using Bluetooth for data transmission and remote monitoring. Patients with chronic conditions can use Bluetooth-enabled devices to track their vital signs and share data with their healthcare providers. Imagine a diabetic patient wearing a continuous glucose monitor that transmits blood sugar readings to their smartphone via Bluetooth. This data can be shared with their doctor, allowing for timely adjustments to medication and lifestyle recommendations. Bluetooth is also enabling new possibilities in telemedicine. Patients in remote areas can consult with specialists via video conferencing, using Bluetooth-enabled medical devices to transmit vital signs and other relevant data. This improves access to healthcare for underserved populations. Bluetooth's role in healthcare is evolving rapidly. As technology advances, we can expect even more sophisticated applications that empower patients, improve diagnoses, and enhance treatment outcomes. Bluetooth has become an integral part of the automotive industry. Modern cars come equipped with Bluetooth connectivity, allowing drivers to make hands-free calls, stream music, and access navigation systems safely. Bluetooth also enables keyless entry and engine start, enhancing convenience and security. Imagine getting into your car, your smartphone automatically connecting to the infotainment system via Bluetooth. Your favorite playlist starts playing, and you can navigate to your destination using voice commands, all while keeping your hands on the wheel and eyes on the road. Bluetooth is also paving the way for autonomous driving. Cars can communicate with each other using Bluetooth, exchanging data about their location, speed, and direction. This vehicle-to-vehicle, V2V, communication enhances safety by preventing collisions and optimizing traffic flow. As autonomous driving technology matures, Bluetooth will play an even greater role in connecting cars to each other and to the surrounding infrastructure. This will create a safer and more efficient transportation ecosystem. Bluetooth beacons are small, low-power transmitters that emit signals detectable by nearby Bluetooth devices. They are used for location tracking and proximity marketing. Retail stores, museums, and airports are increasingly using Bluetooth beacons to enhance the customer experience. Imagine walking into a store and receiving personalized greetings and promotions on your smartphone based on your location within the store. Bluetooth beacons make this possible by detecting your proximity and triggering relevant messages. Museums use Bluetooth beacons to provide audio guides and interactive exhibits. As you approach a particular artwork, your smartphone receives information about the piece, enhancing your understanding and appreciation. Airports use Bluetooth beacons to guide passengers through terminals, providing directions to gates, baggage claim, and other amenities. Bluetooth beacons are becoming increasingly sophisticated, enabling more precise location tracking and personalized experiences. As technology evolves, we can expect even more innovative applications that enhance our interactions with the physical world. Bluetooth technology prioritizes security to protect data during transmission. It employs various measures to ensure that your information remains confidential and secure. Encryption scrambles data, making it unreadable to unauthorized parties. Authentication verifies the identity of connecting devices, preventing unauthorized access. Think of Bluetooth security as a series of locked doors and guarded checkpoints. Encryption acts as a vault, safeguarding your data from prying eyes. Authentication acts as a security guard, verifying the identity of anyone attempting to access your information. Bluetooth security features are constantly evolving to counter emerging threats. The Bluetooth SIG regularly releases updates and security patches to address vulnerabilities and ensure the continued safety of Bluetooth connections. While Bluetooth is generally secure, it's important to follow best practices to minimize risks. Use strong passwords for pairing, avoid connecting to unknown devices, and keep your Bluetooth software updated to benefit from the latest security enhancements. Bluetooth Low Energy, BLE, revolutionized wireless technology by significantly reducing power consumption. This made it possible to create small, battery-powered devices capable of operating for extended periods. BLE is a game-changer for wearable technology, the Internet of Things, and other applications where energy efficiency is paramount. Imagine a fitness tracker that can monitor your activity levels and sleep patterns for weeks on a single charge. BLE makes this possible by minimizing energy drain, extending the battery life of these devices. Smart home gadgets like door locks, light bulbs, and thermostats can operate for months or even years without needing battery replacements, thanks to BLE's energy efficiency. BLE's low power consumption also benefits the environment. By reducing energy usage, BLE contributes to a more sustainable future. As technology advances, we can expect even more energy-efficient Bluetooth solutions that further minimize our environmental impact. BLE's impact extends beyond personal devices. It's transforming industries by enabling the creation of wireless sensor networks that monitor critical infrastructure, optimize industrial processes, and enhance agricultural practices. Bluetooth's journey of innovation continues. The Bluetooth SIG is constantly exploring new possibilities, pushing the boundaries of wireless technology. Future developments will focus on enhancing data rates, extending range, improving security, and expanding applications. Imagine a world where Bluetooth can transmit data at speeds comparable to Wi-Fi, enabling seamless streaming of high-definition video and other bandwidth-intensive applications. Future Bluetooth versions may extend range, allowing devices to connect over greater distances, enhancing convenience and flexibility. Security will remain a top priority. Future Bluetooth implementations will incorporate advanced encryption algorithms and authentication protocols to counter emerging threats and ensure the continued safety of data transmission. Bluetooth's applications will continue to expand into new domains, from healthcare and automotive to smart homes and industrial automation. Bluetooth will play a pivotal role in connecting our world, making it smarter, more efficient, and more sustainable. The future of Bluetooth is bright, fueled by innovation, collaboration, and a relentless pursuit of excellence.